Hi, welcome to Advanced Mathematics, Trigonometric Identities and Formulas, Part B, page 4. You should do this on your own if you can. Check the answer key if necessary, but if you're looking for more information, watch this video. See if it helps. If not, send me an email. So we're going to take the formula that we developed earlier in this section for finding the sine of the sum of two angles, or the sine or cosine of the difference of two angles, and use it for an example or two. So we're looking at sine of 15 degrees, and that angle happens to be an angle that we can express as a difference of two angles that happen to be angles that we do have on the unit circle. You can choose any two angles you want that have a difference of 15 degrees, but if you choose angles that are friendly angles from the unit circle, some rather interesting things result. So we're going to use the sine angle difference formula, which means we'll need to know the sine of angle A and the sine of angle B, and cosine of A and cosine of B. Now, 60 and 45 degrees are nice angles in the unit circle, so these are values that we have at hand. I'm just pulling these off the unit circle. So sine of 15 is the sine of the difference of two angles. So that's going to be sine of A, which is 60 degrees, cosine of B, which is 45 degrees, minus cosine of 60, sine of 45 degrees. Now, all I'm going to do is substitute for each of these expressions. I know what they are because those were on the unit circle. So I'm just going to substitute in here root 3 over 2, root 2 over 2 multiplied together, minus 1/2 times root 2 over 2. And that'll simplify down nicely to root 6 minus root 2 all over 4. So that's kind of cool, actually. The sine of 15 degrees has this very neat, compact, exact expression. In other words, if you go to your calculator and type in sine of 15 degrees, it gives you a decimal approximation. If you then go and evaluate in your calculator root 6 minus root 2 and then divide that by 4, you're going to get the exact same approximation in decimal on your calculator. That's pretty neat. I mean, I think so. All right, let's try another one. Sine of 105 degrees. Again, if we choose convenient angles for that, something like, I don't know, 45 degrees, 60 degrees. Again, any pair of angles that you can find on your unit circle, friendly angles, 30, 45, 60, and so forth, that add up to 105 degrees, you can do this with. So sine of A, root 2 over 2, sine of B, stop and think, root 3 over 2, and then cosine of A, root 2 over 2, cosine of B, 1/2. Now let me scooch this up a bit. So cosine of the sum is cosine, cosine, sine, sine, sine. So cosine 45, cosine 60, and because we're adding here, we're going to subtract. When you're doing the cosine formula, it's the opposite sign, cosine, cosine, sine. Sine of 45, put those symbols in there, sine of 60, and substitute in the values that we figured out for all of those. Cosine of 45 is root 2 over 2, cosine of 60 is 1/2 minus root 2 over 2. Sine of 60 is root 3 over 2. And we get, in simplified form, root 2 minus root 6 over 4. All right. Let's try another. I know, it's exciting. Okay. Ooh. This is different. Okay, so this one's very different. We don't know what the angles are. We know it's a bit of a puzzle. We know some things about the angles, though. We know that the sine of the angle is 3/5, and sine of angle A is 3/5, and we know that the cosine of angle B is 15/17. Now you could go and do inverse sine of 3/5 to get angle A, and you could do inverse cosine of 15/17 to get angle B, but then you'd get an approximate value. You'd get an approximation in your calculator, and you have to carry all these decimals around, and it would be gross, not very pretty. So what I want to do is think about, and these are also all acute angles, which is kind of an important idea. So sine of A is 3/5. If I envision a right triangle, and this is angle A over here, saying that sine of angle A is 3/5 would be saying that this would be true if the hypotenuse were 5 and the opposite side were 3. And if that were the case, then I would know that this should be a 3, 4, 5 triangle, and that this adjacent side should be 4. And that would mean that I now know the cosine of A. Cosine of A would be adjacent over hypotenuse, or 4/5. So we're using facts about right triangles to figure out, if we know what the sine of an angle is, we can figure out what the cosine is, and vice versa. Likewise, for angle B, draw a right triangle for that. Cosine of B, we'll call this angle B. Cosine is the adjacent, so this would be 15, and the hypotenuse is 17. Again, we've got a right triangle. We can use Pythagoras to sort out that this opposite side is 8. That is a right triangle that satisfies Pythagorean theorem. So sine of B, therefore, would be opposite over hypotenuse, or 8/17. Now, sine of A plus B is, so this is just regurgitating the sine angle sum formula. Sine A, sine, cosine, cosine B plus cosine A, sine B. Now, I'm going to use this to fill in the answer here. I now know, based on the information that was given to me and the information that I figured out, what all of these things are. I know sine of A, cosine B, I know cosine of A, sine of B. So let me just write them all in here. Sine of A, that was given, that's 3/5, times cosine of B, which we were also given, that was 15/17, plus cosine of A, we figured that out on our own, that's 4/5, times sine of B, which we also figured out, that was 8/17. We do have a common denominator, which is 85, and if you do the arithmetic on this, you will get 77/85. So this is kind of like this is the magic trick of trigonometry. We were given the sine of the angle as 3/5 and the cosine of a different angle as 15/17, and from that we were able to figure out the sine of the sum of the two angles exactly, without ever getting our hands on the angles themselves. I don't know what angle A is, I don't know what angle B is, and I never needed to figure it out to figure out what sine of A plus B was. And I think that's kind of cool, but that's just me. Okay. Going on, sine of A minus B is going to be exactly like this expression, except there's going to be a minus sign between the two of them. So I'm just going to cut to the chase and write out that expression. So 3/5 times 15/17 minus 4/5 times 8/17. And that's going to be, again, common denominator. It works out to 13/85. And then finally, cosine of a plus b. Remembering now that cosine of a plus b is cosine b minus sine of a sine of b. And I've got all of these values already. Cosine of a, I figured that out. It's 4/5. Cosine of b was given to me. That was 15/17. Minus sine of a, 3/5. Times sine of b, which we figured out is 8/17. Same denominator. Do the math. You're going to get 36/85. And finally, cosine of a minus b. It's the same formula as this one, but the sign is different. It's going to be a plus instead of a minus. So the expression is the same. 4/5 times 15/17 plus 3/5, 8/17. When am I ever going to use fractions, they said. Well, you know, more math. This works out to 84/85. Voila. There's the magic trick of trigonometry.